All right, sweet. So it's gonna be chapter 7, lesson 1. We're starting with ratios and proportions. Again, it is a kind of a good chunk of stuff that we're covering today. So we'll just do all the teaching portion of the day. I'm not gonna have any homework today, but I'm going to have tomorrow be a work day for the entire time. And we should be able to get through everything in the class period. So with ratios and proportions, you guys will be able to write ratios, and then you'll be able to write and solve different proportions. And then also I do have all the blank notes posted on Google Classroom, so that way if you need to see them, if you can't see them from there, they are there. All right, so a ratio is a comparison of two quantities using division. Usually they're written two separate ways. Did anybody remember what some of those ways look like?
Number dot dot is another number.
Okay, so like a number dot dot, so like I could write it as 1 to 4, like that. That's one way to write that ratio. What's the other way?
As a fraction.
Perfect. The other way is just like a fraction. Okay? So for both of those, that ratio that I gave you is going to be 1/4 or 1 to 4. Sometimes they'll try to explain or say that's like a scale model or something like that, but that's what the ratio is. Okay? So when we start to look at these examples, when we start working our way through, what I want to make sure that you understand is the order is important. Of what they're trying to ask for, the order is going to be important. Because depending on how they're asking it, it's going to explain which one would be the top number, which one would be the bottom number. So for like example 1, it says in Logan's High School, there are 190 teachers. There's 2,650 students. What is the approximate student to teacher ratio? The key word there, or the key way that they have described it, is it says student to teacher. Okay, so if I want to figure this part out for the student to teacher ratio, I need to put the student first and then the teacher afterwards. So I could put it at that 2650 to 190. Or again, I could put it as that fraction, 2650 over 190. Whenever we have these ratios, though, usually what we want to do is we want to have them so that one of our numbers is going to be a 1. So in this case, our bottom number, where we're trying to figure out how many students per teacher, so we want the bottom number to be 1. So I'm going to divide that 2,650 divided by 190. So that many students divided by that many teachers. So when I go through, I get and it's going to give me a decimal. It said like 13.947 over 1. However, it did say approximately. So instead of writing a decimal, because it wants to approximate, approximately how many students are there to teachers, Joshua?
What do you divide again?
I'm going to divide both of these by 190. So I want to get my bottom number to be a 1, so I'm going to divide it by 190. So 13.947 is really, really close to 14. So my ratio, I'm going to write it down here. My ratio is going to be 14 to 1, or I can say 14 to 1. Meaning that for every one teacher I have, I'll have approximately 14 students. Okay? On to the second example. It says the number of students that participate in a sport program at Central High School is 520. Number of students in school is 1850. And then it says find the athlete to student ratio to the nearest 10. I'll let you write down some of that stuff first, and then I will talk it out. All right, so this one here, it's looking for the athlete to student ratio. So the athlete to student, meaning I want to set it up with my athlete on top and my students on the bottom. As long as I know how to set up that fraction, I can go through and I can plug those numbers in now. I know the total athletes I had was 520. Total students in the school is 1850. And I still want to find that ratio, so I still want my bottom number to be a 1. So I've got 520 divided by 1850. So 520 divided by 1850. My ratio that I'm given is 0.28 over 1. It did say to the nearest 10th. So my ratio would be 0.3 over 1, or I can say 0.3 to 1. Either way is good. Usually when I'm doing ratios, and my suggestion for you is to write it as a fraction, because we'll be doing some cross multiplying to solve these things later on. But if you want to write it the other way, you most certainly can. So before I go to that second part, if let's say I'm going to use this ratio here. I'm going to grab a different color pen just to show it off. But I'm going to use that ratio on the bottom where it has that 0.3 to 1. In this class, we've got 20 students. Okay, I'm going to use this one as my example here. Okay, we've got 20 students inside this class. How can I figure out about how many students are going to be athletes? Using this exact same ratio, any thoughts? All right, well, I'll give you a clue. All right, for this one, for that ratio, if I had that 0.3 over 1, and I'm trying to figure it out for this class of 20 students, I can multiply the bottom and the top by 20 by the exact same number to figure out about how many students I have. So if I multiplied straight across for this one, My bottom number is going to be 20. On top, I've got 0.3 times 20. I should have 6 students in here. So based on that ratio, I should have 6 out of my 20 students inside this classroom that are athletes, based on this ratio. Okay, if we had 10 students in the classroom, how could I figure that out? Yeah, the exact same thing, except instead of 20, I'd write the number 10. So realistically, what I'm doing for these ratios is I'm going to write those ones with an X or a variable at the end of it. It didn't matter what they were, so it would be 0.3x over 1x, and I can just plug in whatever number I'm using to solve. Same thing in that student to teacher ratio up top, where it said 14:1. To solve for however many, I could set it up as that 14x over 1x. Because no matter what, I'm going to plug in the number I'm looking for into that spot. Do you guys agree with how that worked? Hopefully. I really want to show you that one because this part is where people get confused. Okay, we've got an extended ratio. An extended ratio is where there's going to be 3 or more quantities. Like I could have 1 to 2 to 3, or however, where they're going to have these colons in between it to show that it's a ratio that has 3 specific quantities. All right, you'll see it when I get to the example, but quick refresher for everybody. If I'm looking for the perimeter of something, how do you find the perimeter? We just add up all the outside. Okay, the perimeter is the total length around the outside. Okay, just kind of want to remind you of that once I get to this first example. So again, this is how you write the extended ratios. I'm going to explain how to solve them in a second. Reminder, perimeter is just the total length on the outside. All right, so example number 1. It starts off, in a triangle, the ratio of the measures of the sides is 2 to 2 to 3, and the perimeter is 392 inches. Find the length of the longest side of the triangle. So, just like what I did, I'll scroll up just a smidge so you can see when I wrote those ratios there. How I gave the little x's along with it. I can do pretty much the same thing with this extended ratio. So that 2 to 2 to 3 is the same as me saying 2x to 2x to 3x. Because again, it doesn't matter what I plug in, they'll all be increased by the exact same number if I plug it into the same one. To find a perimeter, it's adding up all the sides, right? So to solve this one, each one of those sides, instead of having it written like this to this to this, I can write it as 2x plus my next side plus my next side, and that's going to equal the entire perimeter, that 392 inches. And as soon as you see how to set it up, does it look so bad anymore? No, it looks like a regular algebra problem that we can do. Okay, I can combine my like terms, 2x plus 2x plus 3x. That gives me 7x. That equals 392. I want to get the length all by itself, so divide both sides by 7. So I get 392 divided by 7. My value for x equals 56. However, I am not done yet. This one, we do have to start plugging things back in. Because again, we are getting the ratios. We know which thing they're all going to be increased by, but we do have to plug stuff back in. It says find the length of the longest side of the triangle. Out of those three numbers, which one will be the largest number? The 3x one. So I just need to make sure I plug this into the one that has 3x. So I'll take 56 times 3. Perfect. My longest side, is going to be 168 inches. Again, we can plug it in. You can plug it into the 2x and 2x and just find the biggest number. But again, the ratio-wise, it's still going to work out the same way. Questions on that part? Okay, I've got one more different type that I want to show you before I jump onto the next portion of it. I'll let you write this one down before I start going into it. It says the ratio of measures of angles in a triangle is 5 to 12 to 13. And then it says find the measures of the angles. So I'll give you a chance to write it. All right, I've got that set of ratio numbers. And then it says it wants me to find the measures of the angles. How many degrees are in a triangle? What? 180. Yeah, 180. So I'm going to do that exact same thing that I did before, but instead of trying to find the perimeter where I add up all the outside, I know that all of these ones will add up to equal 180. So I've got that 5x plus 12x plus 13x. That's all going to equal 180 because I'm finding the measure of all the angles. And that's this 5. That was where the 12 came from. That's where the 13 came from. I add them all together. I should get 30x equals 180. I'm going to divide both sides by 30. X equals 6. And the very last part it's asking me is find the measures of all the angles. I'm going to plug this 6 back in to this one, this 5x, plug the 6 into this one, and I'm going to plug the 6 into that 13. So I'm just going to kind of write it as that extra step just to show you what I'm doing. That 5x, that 12x, and then that 13x. So my first angle will be 30 degrees. My next angle will be 72 degrees. And my last angle will be 78 degrees. The biggest thing to notice in these guys is going to be, if it's asking to find the measures of the angles, you'll make it equal to 180. If it's asking for the perimeter, you'll set it equal to whatever that perimeter number is going to be. Any questions on kind of those multiple numbers with the ratios? Okay. Am I good to scroll down? Okay, I'm not going to get too crazy. I know you guys know how to do this stuff. I'm going to do the first two I'll review. Like I'll do these ones. Then after that, you guys will talk me through it. I'm not going to get into the property because there's no reason to memorize the property when we can just practice the property. So this stuff is going to be cross products. By a show of like thumbs, who remembers doing cross products? I got a good over half and I like it. So again, this stuff is all cross products. All right, the first two again, I'm going to do by myself. Reminder for cross products, it's going to be like this little X sort of thing. So these two are going to go together. And then these two will go together. So as I write it, I would get -6 times X equals 4 times 11. This would turn into -6x. This would turn into 44. And then I want to get x all by itself. Divide both sides by -6. My final answer should be x equals -7.3, repeating. Again, cross product is going to be working across that equal sign. It's almost going to look like an X if you're going to circle the ones you're going to put together. Yes, ma'am.
So for that one, you only solve for x?
Yep, only solve for X. And that's all that it's going to be. It'll be the exact same proportion every single time. So it'd be that 7.3 over 4 is the same as, -7.3 over 4 is the exact same as 11 over -6. Okay, in some later lessons, we'll do it with the actual shapes that go along with it. But as long as you can get to this setup as this cross product step, it won't be a problem. So one more time, these two will go together, and then these two will go together. So I get 6y equals 9 times 18.2. I get 6y equals 163.8. And then I want to get the y all by itself, so divide both sides by 6. My final answer for this one is 27.3. Okay, I got a couple more samples that I'm going to have you talk me through how to do. I want to make sure you guys have it. Good? Okay, so I'll start off with number 3. This one here. You guys talk me through which parts are going to get multiplied together.
The 6 and 7 are gonna look like that.
Okay? Yep, those ones are going to get multiplied together. And then the other two. All right. Okay. Perfect. It'll be the top 2, or so the 2 that I put yellow. That 6 and 7 will multiply together, and then these 2 will get multiplied together. When I am going to start to solve this one, okay, I still have that 6 and 7 are going to go together. I'm just going to write it over here, 6 times 7. However, that blue stuff looks a little weird. So the way I'm going to write it is I've got that 2y plus 5. All of this entire bottom thing is going to get multiplied by 4. So when I write it, I'm going to put it in parentheses, so that way I know I have to use distribution to get there. Okay, so somebody talk me through. What do I do with that 6 times 7? Or what is it? 42? Okay, on the other side of the equation, where I have that -4, then I have the parentheses of 2y plus 5. Somebody talk me through what I'm going to do there. Okay, Ricky, how do I do that? Which is? How about -8?
I thought of negative. Oh, yeah.
Okay.
-4 times 5.
Awesome. Yep, you're right. Okay, multiply straight across. I get that -8y minus 20. Now it just turns into a regular problem I can solve. Anybody want to talk me through those last 3 steps? Just do the problem for me. So add 20 to both sides. Love it. I get 62 equals -8y. And then? Awesome. Divide both sides by -8. So I got 62 divided by -8. My final answer for this one is going to be y equals -7.75. Feeling good? Okay, you guys do this one on your own then. Actually, I'm going to skip down to this one. Do this one on your own. Exact same way. Also, it's just the 7. It's not this 5 in front of it.
you also distribute the 9?
Yes. Yep, it'll distribute the 9 to both sides, and it'll also distribute the 7 to both sides. Nice. Yep. Yep, so this 9 we distribute to both. So it'd be to the Z and to that 1. All right, I've got just over a minute left. So I know some of you guys are still working it, but I want to make sure that I can show you this last part before the class is over. So when I distribute, that should have been a highlighter. Don't back up yet, I got some time. These ones will get distributed together. These ones will get distributed together. So I should have 7 times Z plus 4. Z plus 4 equals 9 times Z minus 1. That gives me 7Z plus 4, or sorry, plus 28, because I need to distribute all of that, equals 9Z minus 9. Okay, now I'm going to get the Z's on the side by itself, minus 7Z minus 7Z to both sides. I get 28 equals 2Z minus 9. So plus 9 to this side, plus 9 to this side. I get 37 equals 2Z. Divide both sides by 2. My final answer should be Z equals 18.5. Any questions on the last one? Yes, ma'am.
It looks fine.
It
sounds like slinky and short.
I'll wait till I don't do anything to it.
You're like a hair implant. You're like not a question. You're like,
Well,
you grew up. I was like,